that session, let me clear you that what is the main objective of this session and what we will try to learn from this session. So I will discuss some security threats. Okay, I think I'll consider few security threats, 4 or 5, maybe all that security threats to known to the participant, and we have listened about that security threats. That these are the security threats are there. But today, my target and my objective is that how that security attack or threats that attacker can execute that security threats. That things I'll try to prove with the help of some mathematical equation and some cryptographic algorithm. And then the next part will be how we will protect it. For example, some security threats I'm considering. And based on that security threats, what should be the technique to protect that security attack so that the attacker or adversary cannot break that security attack, right? So that is basically the main objective of this topic. So these are the outlines that I will follow, like introduction, type of cryptanalysis, some Kirchhoff principle, some protocols, okay, how to do that protocol, right? And then I'll consider one example of authentication protocol. Based on that, how to do the cryptanalysis, right? So that these are the things that I'll be discussing. So certainly we cannot understand that these are the methods or these are the techniques we can do the cryptanalysis, or we can break the security system, right? So before that, some basic understandings are required. Maybe some of the participants are from CSE background, maybe non-CSE background, or maybe some other background, right? So considering all that, first few minutes, like 20 minutes, I'll be discussing that basic understanding how to do that cryptanalysis part. Okay, so first all that things I'll be discussing, and then we'll go the main part. So this word is very much important in the domain of cybersecurity or network security. That is basically called the cryptanalysis, right? So this cryptanalysis means we have that always that attacker or the adversary will have some target to break the protocols or to break the security system, right? Already we know that there are some protocols are being used to build the secure system, right? And many of the secure system nowadays we are using also. And for that secure system, different kind of protocols are being used, right? So definitely that protocol means there are several rules and some equations. All the things are there. So if the attacker are getting that protocol, what are the loopholes or what are the shortcomings are there in that protocol, and based on that, the attacker can do the cryptanalysis. That means that attacker can find out some security attacks, right? So that's why it's telling that cryptanalysis is the art of trying to decrypt at the encrypted message without the use of the key that was used to encrypt the message, right? So here already few sessions has been done previously. I hope so all these terms are very much useful for you people, like encryption, decryption, okay? And some algorithm like RSA, ECC, or some crypto function like cryptographic hash function. So all these things will be used basically. So here this cryptanalysis, if you want to do basically these three things, like amount of time available. For example, there is a one protocol or algorithm. If you want to break it, so how much times are there with you? So that is also important, that so time is required, right? Computing power, and that is also most important because this computing power is required. That means if you want to do some kind of computation from the crypto equation or cryptographic some algorithm, so you need some computing facilities. So computing power is also required. If you want to store some kind of information for further use, right? Today, some protocol we are executing and it's producing ciphertext, right? And that ciphertext might be, for example, after 3 months or 6 months or 1 year, you want to decrypt it for your personal reasons or for some other purpose. So what is that? You have to store all that information in some memory, right? So storage capacity is also required. So what is your understanding? Understanding is this. You see that basically there are two games, one game, and in that game, two parties are there. One is designing the crypto system, and another party, who is generally it is called attacker or adversary, is trying to break the security system. So when can a attacker or an attacker break the security system? Definitely when there will be some kind of security loopholes, then only the attacker can break the security system, right? So here some Kirchhoff principles. So this is very much and well-known principle. What it's telling that, so the attacker can break the security system. So if he want to break the security system, he should have a knowledge about that, what kind of algorithms has been used, what are the protocols are there, okay, what are the public informations are there, right? So there are several factors. So from all that factor, Karkov principle is telling that attacker knows every details of the cryptographic algorithm except the key. I hope you're understanding these things, that how much challenges are there, and we're giving more advantage to the attacker. So here, this is the game. So in this game, we are giving more advantages to the attacker, that attacker knows everything like all cryptographic algorithm. For example, we are using AES algorithm. Okay, so attacker knows in that AES what are the steps are there, what are the how many rounds are there. Or for example, we are using RSA, right? So for that RSA encryption algorithm, decryption algorithm, all that things known to the attacker. But one thing he doesn't know, that is basically the key. It means what? It means that crypto system or a particular security system is fully dependent on the key, right? So if that key is disclosed in some way, then that security system may be break, right? So this is basically the Kirchhoff principle, and for that there is a reason also that why that Kirchhoff principles is telling that only attacker knows that cryptographic algorithm. It's telling that easy to maintain secrecy of a short key than to maintain secrecy of algorithm. Try to understand. The point is, for example, the question is, there is two things. One is a key, another one is algorithm. Okay, and if we want to maintain the secrecy of a key and algorithm, which one is easy? Definitely the key is easy, because you can keep the key in some place or with you, okay, but you cannot maintain the secrecy of algorithm. For example, let's take one example. For example, one of the participant is working in some industry, and he has developed an algorithm, and that algorithm is working for a particular application, right? And he is telling that, okay, I will not what is that make it public. But later, after 1 year or after 2 years, if he is leaving that company, resigning that company, and if he is going to the another company, maybe he will reveal all the steps, all the things of the algorithm, right? So that's why that's important point, that we should not that consider that algorithm is private. If algorithm is private, then it will be very much difficult to the attacker to break the security system. So here only one thing we are considering. So details of algorithm can be leaked by an insider or maybe a reverse engineer. Or for example, I'm working in a company, I have designed, and that algorithms I am disclosing to some other people. Okay, and they are breaking that security system. So that's why here this thing is considering that key is only the private part or private keys. Okay, another thing is easy to change a compromised key. For example, somehow that key has been compromised. Okay, so in that cases, you may have some algorithm to change it or to update the key instead of that algorithm. because replacing and updating the algorithm is much costly, right? So that's why it is considering, and why I am discussing means slowly I will take your mind that how the attacker is trying to break the security system, and for that what kind of advantages, what are the powers or capabilities are there with the attacker. So from these slides, what we understood, that the attackers are only having the all the details except the keys, right? So this is basically the Kirchhoff principle. Some other models, symmetric related attack models, we'll see over here. For example, attack model 1, ciphertext only attack, known plain text attack. Okay, already you know the meaning of, like, for example, ciphertext and plain text, right? And encryption decryptions model. So let's consider ciphertext, right? So whenever we're using some encryption algorithm, for example, AES, right? So after performing the encryption algorithm, it will produce a ciphertext, right? And if I'm telling that this is the ciphertext, and if I'm telling you that you try to find what was the plain text, it's much difficult, right? But if I'm telling you that keys, whatever the keys has been used for the encryption, that is with you, then you can easily you can easily get the plain text by using the decryption algorithm, right? So here, that in ciphertext only attack, we are giving that ciphertext, set of ciphertext to the attacker, and the attacker will try to find the keys or the message. There, it means here two things. The objective of the attackers are two things, that attacker will try to find the message or the key. So it's similar way, in case of known plain text attack, the attacker knows that M1 and C1, okay, that means he knows the plain text as well as ciphertext, but the target is to find the key. So you see that ciphertext only attack and known plain text attack. So from these two attacks, what is the understanding? The understanding is, in case of ciphertext only attack, it is much difficult than known plain text attack. Why? Because in case of ciphertext only attack, only the attacker knows the ciphertext. Other things like what is plain text, what are the keys, that he doesn't know, right? But in case of known plain text attack, it is telling that the messages, whatever the plain text are there, as well as ciphertext are also there. These two things we are going to provide to the attacker. From that, what is the target? The target is to find the key. So what are which key is been used for that particular encryptions to produce the ciphertext, right? So here, chosen plain text attack. So here also, what attacker will try to do, attacker will choose like M1, some plain text. It will give to the encryption oracle. Encryption oracle means it's a kind of, you consider it as a algorithms only. From that, it will get the ciphertext. So from here also, the target is to find the key. In case of chosen ciphertext also, here you see, main the target is to find the key. So that's why I told that time, in case of Kirchhoff principle, that always attacker will have a target to find the key, because if you know the keys, okay, you can break any security system. Okay, so here from this attack model, what are the things? The things are, we are giving one by one advantages to the attacker to get, so that they should try their best to find the key, and if they are getting that key, then they will get the success. But what is our goal and what is our motivation, or what is our objective? Our objective is, we will design the protocol or that algorithm or the key size in such a way so that the attacker cannot get that key and cannot break that security system, right? So few example, if you see, basically, if you are categorizing that security threats, we'll get two, that is active attack and passive attack, right? So in case of active attack, the attacker will try to modify some kind of message. What are the message you are sending from Alice to Bob or sender to receiver? In case of passive attack, only it will get the information, and it will monitor the channel, and it will get the information, but it will not modify the message. So these are the very well-known attacks. I hope most of the participants you have listened, like man in the middle attack, right? Theoretically, we know that what is man in the middle attack. There will be a man inside this Alice and Bob, and it will try to execute that man in the middle attack so that it can get the secret information or confidential information, right? We have seen. But today, considering one protocol, how this man in the middle attack can be performed, that part I'll be discussing. It's like that some other attack like replay attack is there. DOS attack, denial of service attack, or distributed denial of service attacks are there. Okay, impersonation attack, how to impersonate for a particular system. For example, that you are using your login credential and someone is trying to use your login credential. So that is basically that some person is trying to act as a valid user like you. So that is he is trying to as a impersonate. Okay, and most is password guessing attack. I will be discussing today also that password cryptography. And then brute force attack. Okay, it will try to find all kind of possible keys, and the most important, that is basically called the insider attack. And then there is a phishing attack. So these are the just some example just to keep in your mind. Just only few I have considered over here, but there are several security attacks. That security attacks, and the attacker are using their intelligence to break the security system, right? Now let's consider that password cryptography. Okay, what is that password cryptography? Why I have considered this thing? Because you see that in case of cyber security, what I understand that in case of if you want to break a system, one of the confidential information is the password, right? And we all are using that password every day, right? And it is why we all are using that password, because this is the very easy way to use, and it will be used for the authentication purpose, right? So that's why that password are most commonly used for the authentication, because of easy implementation as well as easy to remember. Okay, for example, if instead of password, if you are using some other technique like biometric, maybe it will be some costly, maybe some implementation issue, some other kind of problem we'll face, right? And what is that password? Already we know, right? That there will be some character, some what is that special symbol? Okay, so we everyone we are using this password, and this is basically passwords are human memorable, considered as a vulnerable in security. Okay, so human can memorize it. Okay, so for that, human will use some kind of easy password or low entropy password, right? So for that, password creations rule have been enforced to increase the quality of password, right? So these are also, we are experienced that in case of password, that they always recommend to use, in some cases nowadays, they will not allow to use that easy password, right? For example, simply you are writing 1 2 3 4 5 6 or your name or date of birth, so they will not allow you. So for that, you have to use the combinations of letter, numeric, non-alphanumeric, passphrase. Okay, so and also you have to minimum 8 character password should be there. Maybe in it depends. Okay, it depends in different mechanism that they may use. Okay, but the thing is, it should be human memorable, right? And once it is leaked, now you think that, for example, once it is leaked, then it will be very much easy by the attacker or adversary to break your system, right? So that's why it is the password is most confidential, most sensitive information, and we should provide higher level security to the password. So there are several techniques. I hope you people have listened also. You have seen that some newses also that day by day that from there some passwords are being leaked. Okay, and there are several mechanisms also, so that from that we can get a password. Okay, for example, keylogger are there, and network sniffing tool can be also used. Okay, we can guess the password, right? and some kind of mechanism we can use to gauge the password also, right? For example, why? Because if you are using some kind of easy password, then it will be very much easy by the attacker, or who is going to break your security system. Okay, if you are using easy password, it will be that attacker can easily get it. Okay, so these are the some technique. Some other techniques are also there, so that things also I'll be discussing. But where the security is required in case of password, here one sentence you can see that passwords are not truly random. If I'm asking you, can you tell me that is passwords are random? The answer is not, it's not truly random, because in this password also some boundaries are there. Okay, so in this boundary you see that we are having a 52 upper or lower case. Okay, digits are also there, 10 digits are there, 32 punctuation symbols are equals to like that. Okay, so in that cases you have to choose from here only. And some intention is, if I'm telling you, just after few slides, I'll tell you something related, some important informations about password, that people like to use dictionary, word, relative or pet names. Okay, so these are the very 1 million common password. Okay, so people basically they use because everyone wants that type of password which we can keep in our memory very easily. Okay, and on an average each person is having 8 to 12 password. Okay, if you can also see that you are also using password for different accounts, different system impose different password requirement. That is also nowadays very much important. And why? Because for example in some system it's telling okay, you can use 8 character, you can use 10 characters, you can use 12 character. Okay, even some security, some system will tell simple password also you can use. Okay, and another thing, that password needs to be changed often. That is very much important. And some password are only used occasionally. So this is also another important issue, that we are creating a password for a particular system and we are forgetting it because we are using maybe after 3 months or 4 months. Okay, so okay, there is a some methodology that we can forget. But these are the information I'm telling because again that we need high level security on the password so that the attacker cannot break the security system. So these are the well-known password related attack. I hope it might be you people are familiar, like for example dictionary attack, right? So dictionary means most people use real world as a password, so we should not use, right? Because there is some algorithm. From that algorithms it will not take much time, only maximum I think 2 to 3 minutes it will take. If you are using dictionary word as a password, it will break easily. Okay, then brute force attack, it will try all possible combinations. Rainbow table, there is a rainbow table attack. In this rainbow table some plain text and some MD5, means that some hash value is there. Can you find the password? Bob cannot find the password because that password has been stored in the form of hash value. So from that hash value, that Bob or any person or any attacker cannot find the original value, right? So here it is providing one of the solution to protect the password. But what is your understanding? So is this method is fully secured? No, this method is not fully secured because only we are storing, you see that H of PA, that means only the hash value we are storing. Although it is difficult, but there are several mechanisms. From that mechanism you can get it. If you are using a low entropy password, it means that password, if you are using a dictionary password or some relative names or pet names or some what is that low entropy information, common names. Okay, so from that the attacker can use some kind of algorithms to get your password from the hash value. But if it is a high entropy information, that means the combinations of several values, okay, then it will be very much difficult. Okay, So here you see that here it is providing some kind of security on the password, and I want to provide a more than this system. So here another technique is being used, and that technique is called the salting technique. So in this salting technique, instead of storing the password alone, we are concatenating another value, and that value is called the salt value. Right here you can see that assay is mentioned, and this assay is called salt means it's a some kind of random information, right? So that random information, and you see that password. What is the password? The password is PA with concatenations with SA. That means we are merging these two information like PA and SA, and then whatever the hash value are there, hash value is there, that hash value we are storing as a password, right? So you see that the security level. So in the first case, simply we were storing the plain text. So it can be easily find out, right? In second case, only we are using hash of PA, right? Hash of PA. So in case of hash of PA, it's providing a security, but it's not a high level security. But here you see that salting level. So salting technique we are using. So this is, we can call it as a high level security we are providing, because if the attacker want to guess it, try to understand here that if the attacker want to guess it, only that PA value, whatever that PA value is there, the attacker should guess PA value as well as SA value together, right? Then only the attacker will get success. So if in case of case 2, the getting success of the probability might be high, but here the probability will be low, because that attacker has to guess PA value as well as SA value together. So here the probability will be low. But here the attacker has to guess PA value as well as SA value together. So here the probability will be high. 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 Right? So definitely the probability of guessing these two informations, okay, and in case of guessing the password, the probability will be low.
Hello, sir.
Another important, so
Hello.
yeah,
Sir, in suppose
yes,
I just encrypting hash of password, how can break them? Only if there is no salt.
there is no salt. Yeah. For example, H of PA is there. For example, two things. Password might be two types. One is low entropy, another one is high entropy. For example, you are using some dictionary word, right? For example, you are using here the password. For example, you are using tiger, right? So H of tiger means what? It will give some kind of bits. For example, MD5 you are using 128 bits. So they can do the dictionary attack, right? So from dictionary first word so to last word. So continuously it is calculating the hash value and it's checking whether it's matching or not, right? It means what? It's a guessing. So instead of guessing, for example, I'm telling you that what is your understanding? For example, guessing two parameter is easy or guessing one parameter is easy? Definitely two parameters are easy. Difficult, right? So single parameter, for example, single parameter you are considering, so that is very much easy. So here simply we are using a single password, single parameter PA. So that's why the attacker can guess, but we cannot tell that 100%. But if your password is low in entropy, means the information is that not that much random, then it can be easily guessed. But here you see, so just to provide the little bit higher level security, so that's why we are using another information, right?
Okay, okay, okay. Thanks.
So here that another information means that you have to guess two things at a time, right? So you have to guess two things at a time, which is a little bit more difficult than the previous one, right? So this is the way you see that how the security level can be increased. Now the next point and the next topic is insider threat or insider attack. So here, so this is the thing from the literature that mostly whatever the cyber related problems or cyber related attacks are happening because of this insider attack. So let's try to understand what is that insider attack. So insider attack means now you assume that you are a client one, okay? And in this client one, you are having a multiple account. You are having a multiple account. And in this account, you are using one password, okay? And in case of account 2, you are using another password which is not same. In case of account 3, you are using another password which is not same with account 1 and account 2. That means what? You are using different password. If you are using in that way, then there is no issue. You are safe. Why? Because you are using different high entropy password, which is very difficult to guess. But what is the problem? The problem is remembering. You cannot remember that 10-15 password every day, right? So in that cases, you will forget it. Okay. So to solve these things, what we human mentality, what we used to do that for every account, we used high entropy password. And for every account, it as per my understanding and what I know that for every account, there will be a same password. Password is high entropy. Like for example, some what is that lower character, upper character, some special symbols, some numeric values. Okay, so combinations are there, but that combinations you are using for every account, right? You can now check yourself, right, that you will get a same password for the different account. For example, now you are using this same password for the different account. What is the problem? Is there any problem? Yes, definitely there is a problem. The problem is you are trusting account 1 and you are using the password. Also you are trusting account 2 and also account 3 and other accounts. For example, account 1 is somehow disclosing your password because you don't know what kind of mechanism that account 1 is being used to store your password. Simply in case of logging into the system, we used to provide our login credential, okay, but we don't know what kind of mechanisms in the backend that they have used. Right now, you consider that in, for example, account 1 has revealed your password. It means what? The rest of the account are also in danger, right? So this is basically the problem of the insider. So what we have to trust, okay, to the administrator that for every account that so that they should not reveal the account. So this is basically the problem of the insider. Okay, so up to this point that I told about different kind of password related attacks. Okay, now I'll move to the some other attack and we will see that how we can execute that different kind of security attacks. Okay, so first attack we are considering that is basically called man in the middle attack. I think it's very much well known to all the participants. So here you can see that in case of man in the middle attack, that user and web applications that they are having some original connection. Okay, they are communicating with each other, sending some confidential informations, doing some kind of transactions. Okay, but what is that man in the middle attack? Man in the middle attack is telling that if there is some loopholes in this protocol, whenever they are using this original connection, right? If some loopholes are there, so their attacker can create or attacker can compute some kind of parameter or information as a middleman, and he will establish a new connection, okay, to the web application as well as with the user. But user and web applications, they will believe, or user and server will believe that they are communicating with each other, right? So third person, that attacker will get the all the informations of the user as well as the web application. Okay, how it is? For example, user is using some kind of symmetric algorithm to send the data to the web applications, right? The same kind of algorithm is being used to encrypt the data at the server side or web application, right? So if you want that key is what is the key for this user and web applications? That key, if somehow that middleman is computing, right, then that middleman or this attacker will get the informations of all the user as well as the web applications. So we'll see that how we can, or man in the middle attack, or man in this attacker can create or establish a new connection with the user as well as server. So here you see some kind of already few things I told about the power of the adversary. That means the attacker. Okay, attacker is having the control, full control over the connection. That means that attacker can delete, modify, okay, drop the message, modify the message, and attacker also knows that information. Okay, that means that encryption algorithm, decryption algorithm, whatever the other crypto systems are being used, that crypto system also the attacker knows. Okay, so here we are considering one cases. So in that case, that for example, a user, that user is using a smart card, and in that smart card some informations are stored, and that informations are helping to the user to log in into the system, right? Considering this scenario, this, for example, assumption one, assumption that some kind of information to the adversary, like whatever the information that crypto information we are storing in the smart card, all that informations can attacker can get. That means, for example, that we are storing A, B, C, D, four parameters in the smart card. If that smart card somehow lost, the attacker can get all the informations from the smart card by utilizing the power consumption technique, right? Another point for the adversary is adversary can guess that password if it is low entropy, but adversary cannot guess that identity and password together. That means I show in the third case, you see that in case of solving, so finding two information at a time or guessing two information at a time, which is very difficult. Okay. And there is also another assumption in case of this system, that it also assumes that the valid user can provide. For example, you are the valid user in that particular system. So from that system, you may act as a attacker also, right? So that can be also considered, right? So here, these are the credential having with the adversary. So for example, this is the network architecture we are considering overall. Like for example, user is there, so that users
দেখো
trying to
এই যে এইটা একটা ফাংশন, তো এটা একটা
okay.
ফাংশন, ধরো আমি লিখে দিলাম যে এটা ডি ইজ ইকাল টু এটা।
Okay, so here users are there, so users are trying to access that multiple server. Here I have considered as a cloud. So here multiple server with the help of controls on control server, right? So for example, if we want to or trying to design a protocol for the secure communication between the user and the cloud server, right, there are needs some phases. So in case of this architecture, that three entities, one is user, another one is cloud server, and another one is control server, right? So user can perform the registrations with the control server, as well as cloud server can also perform with the control server. So here, after performing the registration, then only that user can get the access of any particular server. For example, this is the network architecture. Okay, so based on this network architecture, we may design one protocol, and based on that protocol, we may get service from the cloud server or some other server, right? So if you want to do that, we need some registration phase, okay, some login phase, and some authentication phase. So the important is, first the user has to complete the registration phase with the cloud control server, and during the registration some informations will be stored in the control server. As the cloud will give the services to the user, so cloud server will also store, sorry, that control server will also store some information of the cloud server, right? So considering this network architecture, so this protocol has been designed, and this is the one kind of protocol which is hash based, just for the understanding purpose, right? So in this registration process, you see that there are two authentication factor like identity and password. It is submitting to the control server, and after submitting, it is computing some information, some security parameter like ZI, VI, BI, and CI. Okay, I'm not going in details that how they have designed. I'm telling you that you consider that these are the security parameters they have designed to make the secure system for this particular network, right? So JDI they have used with the help of some hash value, like for example, this is hash value, ID, and password they have used. They have used sorry, some concatenations as well as XOR operations also. They have stored some information, and finally you can see that in the user smart card they have used that JDI, VI, BI, and some what is that hash function they have used. That hash function information has also been stored in the memory of the smart card. Okay, so in this way that all the user can complete their registration process. And as the service provider server wants to also provide the services to the user, they have to also register to the control server. So in that cases, so in this way, that service provider server is registering with the cloud control server, and after registering the control server, it is storing some kind of informations in his database, and also it is storing some kind of informations of the user. The most important thing and the thinking is, once the user is completing his registrations with the control server, it can get the access from any one of the cloud server, right? So that is basically the main beauty of the multi-server communication. So after performing this that registration of the service provider server, if the user wants to log into that system, the user will submit these informations like identity and password, and then he has to choose that what kind of, to whom or to which server he wants to access. Okay, out of all these, which server he want to access. So for that he has to choose this identity as SIDK. So in that cases, after that, these are the informations has been computed by the smart card, and finally it is checking some kind of conditions whether the password is provided by the user or correct or not. If it is correct, it will generate a login message. That means from the user side, it will go some kind of message. So here you see, again, I'm coming this network architecture that user is if you want to log into the system, for example, this particular server, that user will send the some parameters to the server. Server will first check the authenticity, that means authentications of the user, and after performing the authentication, that cloud server will compute. That means this server will compute some informations, and it will send again some parameter to the user, and that user will check again that whether this server is authentic or not. And that is basically called, and that is basically done the mutual authentication. That means they are authenticating with each other before getting or providing the services, right? So here also we are doing that login message. It is sending, this user is sending the login message to the cloud server. That means one of the server. So after sending this login message, there are several equations that they have used. So after user that is correct or not. If it is correct, it will compute some informations and again it will send. For example, you see that AI, DI, FI, TI. So all these informations after computation, it is sending to the service provider server, right? Service provider server, that is by the control server. So here 3 parameters they have considered. So after computations, again the service provider server, it is computing and it is sending some informations to the user of the smart card, that is the parameter FI and TI. So in this way, they are calculating some parameter and they are checking the authentication of all the entities, right? Before getting the services, they are generating a key. That key, that is basically called the SK, and to compute that, these are the parameters used. Okay. Now you consider that user is having on key, for example, K1, that the same key is there with the cloud server or this server, that is also K1. If they can perform these things after the authentication, now they can they can use that asymmetric key cryptography, like for example AES or some other crypto system, symmetric key crypto system, AES. Then they can utilize that key for the encryption, and at the cloud, at this server like cloud server or some other server, they can decrypt it. Again they can encrypt some informations and can send to the user can also decrypt it. So what is the target? The target is, after executing this protocol, they will get a common key between the user as well as the server. So once they are getting several symmetric key crypto algorithms are there, that crypto algorithms might be using for the sending the data securely to the either to the server or to the user. So that they have done with the help of this registration phase, login phase, and authentication phase. And you see that several security parameters are also there. Now the target is, for example, this is the security parameters and this is security protocols that as a researcher, that some researcher has designed this protocol, and the target is that how the attacker can break the security system. Now here, this, for example, offline identity guessing attack. What is the target? Target is here in this protocol, throughout this protocol, who has designed this, he is telling and he is what is that, claiming that my identity, whatever the identity of user is having, that is private. That means no one can compute or no one can guess. But here you see that attacker can guess the identity. For example, from the login phase, if you see that crypto equation, that attacker can compute the value of N1. Okay, with the help of this MI and H is that means 2 times hash function. Okay, so after computing this N1, attacker again can get the value of TA, and then finally it's getting the equations like yi equals to TA XOR IDI. And finally here the attacker is computing some other parameter also based on the public parameter and private parameter. Here another important thing I should mention, that whatever the parameter we are sending from user to control server or control server to another service provider server or service provider server to user, so all that informations, all that parameters can get by the attacker because they are using a public channel. Okay, so based on that, some private informations and some public information are there. So in case of step 4, you see that ZA equals to TA XOR IDI XOR of hash of TA and IDI. So what does it mean? It means that ZA parameter is known to the attacker, TA is also known to the attacker. Now IDI guess, that means one by one the attacker is guessing the identity and it is checking and it is verifying whether that value of ZA is matching or not. If it is matching, then the attacker will get the easily identity of that particular user. Okay, so this is basically the process, the guessing process or guessing algorithm, we can say, that the algorithm the attacker can use. So what you see that the attacker, what they have done, several parameters that attacker needs to generate this equation JDA equals to, and in this equation you can see that TA is known to the attacker as well as identity is only unknown. Okay, so now as identity is only unknown, so he is putting or guessing some identity and it is checking the correctness. If it is getting success, then the attacker will get the identity. So this is the offline process that identity can be guessed. In similar way, for example, there is a one equation like Zi equals to H of identity PWI guess and H 2 times of hash function. Okay, so here you see here Zi equals to, there some Zi, you can see that Zi value. You see that Zi value. So from this equation, Zi equals to. So here Zi equals to. So from this identity already known to the attacker, this value is also known, and from that it's trying to guess that PWI. Okay, PWI means that's a password, right? So in this way that the attacker can run or execute algorithm to guess the password. It means what? If the attacker wants to guess or to find some kind of security parameter from the protocol, first the attacker should know the description of the protocol. That means which parameter is being used for what purpose, how many public parameters are there, what are the parameters are being used or sending to a public channel, right? So all these analysis are required. So like that, impersonation attack are also there. So impersonation attack means, for example, that attacker is trying to act as a valid user. Okay, so in that cases, for example, if the attacker is trying to act as a valid user, then what the attacker should do? The attacker should, you see, attacker should generate the correct login message. Okay, so if the attacker can generate the correct login message, then only the attacker can impersonate as a valid user. So if he wants to calculate it, so he is considering some based on that protocol description, he is getting some kind of equation or some parameter and is computing value of OI. Some CIDI value is calculating. You see that MI is also calculating and EI is also calculating. What I told you, if you see the description like SIDK, which is public information, CIDI is also public, but it is calculating MI and EI. To calculate MI value and EI value, it needs some secret information. So accordingly, that attacker is trying to calculate it. So MI value and EI value. So EI value is H of YI, some NA, some identity, right? And it is sending to the service provider server. So if, for example, this attacker, after sending that attacker, if all these informations is going to the service provider server, and if it is accepting, then what? Then the attacker, ultimate, this message is not sent by the user. This message is sent by the attacker. Okay. So then the attacker will act as a valid user. So in this way, the attacker can impersonate into the system by generating all these messages. Okay, so this is the user impersonation attack. So user impersonation attack is a kind of part of man in the middle attack, right? If there is a impersonation attack in a particular protocol or in a particular system, that man in the middle attack is also possible. Okay, so this is basically the analysis from my side, but I want to conclude the session with one thing, that whatever the security attacks I have discussed, and based on this protocol also, because very frankly, I'm telling you, understanding the protocol is not a easy job, especially within this time frame. Okay, it will take much time to understand it. So if you are going through it, okay, and if you are having some kind of motivation and intentions to design that this kind of security attacks, right? So what you should do? So you should do first, for example, that what kind of security attacks are there for that particular system which you going to design, right? For example, you consider one wireless sensor network scenario, right? So in that wireless sensor network, for example, there is a base station. In that base station, some sensors are there, okay? And there is a user. That user can access the data from the base station, and the sensor is sending the data to the base station, and that data is accessing by the user. For example, this kind of network scenario is there. So if you want to design a particular protocol for that particular network model, so the first important thing that you have to analyze that how many security threats are there and what are the security threats. So first you have to list it down, and then one by one during the designing time, you have to protect all the protocols. For example, this paper, I have taken this paper from some research article, and this is very old paper. Just for understanding purpose, I have added that some security attacks are there. But if you are going through some other paper, maybe finding attacks will be very much difficult, right? So these are the things that we have to consider, that how many security attacks are there. For example, password guessing attack, you have to protect. Offline identity guessing attack, if it is related to identity and you want to provide the anonymous into the system, right? Man in the middle attack, you have to protect. Impersonation attack, you have to protect. Replay attack also you have to protect. So for that also you have to use some kind of mechanism. So these are some common attacks, that attacks you have to protect if you are having intentions to design this such kind of protocol. Okay, so this is the designing part. And after designing, definitely some kind of simulator that you might be using to check whether whatever the protocol you have used, whether that protocol is correct or not. Okay, so for that some simulators are there. That simulators maybe that you may use. Some kind of analysis are also required. Okay, that whether the security attacks are exist, whatever the protocol you have designed, or from that protocol, whether there is any security attacks or not, right? So this is basically that the analysis part from the protocol. Okay, so this is all about from my side. Okay, maybe the participants are having some doubts or question. Okay, so you may write in the chat box or you may ask also.
Hello, sir.
Thank you so much.
Hello.
Yeah.
Sir, can you
Yes.
tell me something about attack model, DOLE model, or CKY model? What is the difference between them, and what we have used in this model?
So that attack CK model, DAY-5 model, that already I think that when I was discussing about that power of the adversary, right? So that kind of things based on that network, whatever the network you are considering. Okay, so in that network, what kind of security threats will be there? So that you have to consider. And other, like I told you that dropping, modifying, updating. Okay, so this kind of CK model, DAY-5 model they are considering. Okay, and also, for example, they are that in that model they are also considering that whatever the public messages are there. For example, you are sending through a public channel, that can be retrieved by the attacker. Some kind of assumption, that means we are giving some kind of parameters to the adversary that can be considered through that model. And these are the standard model, because based on that standard model you have to design the security protocol and you have to do the security analysis. Okay,
Is there any attack model, CKY model, or DOLE model?
Is there any?
Except the DY model or CKY model?
No, sorry, I didn't get your question.
Any other exists? There is any
No,
exists except
these are the very standard model, right? So whenever we used, for example, for security analysis purpose, we use, these are the, we basically consider that these are the standard model, and based on that we used to do the security analysis, right? But
Okay.
if you can design a new kind of model also, that can be also, you have to prove as a secured, but these two are the standard model for the security analysis purpose.
So, is there any mandatory for consider these
Yes,
two
yes,
model or
yes,
any?
yes. No. Mandatory means what? For example, for this kind of network architecture, definitely you have to consider, because all are very common, right? For example, whenever you are designing, so that time definitely you have to consider that, okay, your message might be dropped, or your message might be what is that, modifying also. Okay, maybe that's that as a valid user you are disclosing some confidential information also. So all that adversary power or attacker power has been discussed and mentioned in all that threat model.
Okay, thank you, sir.
Okay, thank you so much.
Thank you, Dr. Ruhul Amin.
Thank you so much, sir.
Please on your camera.
It's visible, sir. I think there is some problem in my camera. I was trying to resolve it, stopping my presentation. Okay, I think some issues are there, sir.
Maybe there may be some issue. No problem. But I would like to request all the participants, please open your camera, on your camera. We are just going to take a screenshot with our expert. By the way, thank you very much, Dr. Ruhul Amin. You have covered in details different types of protocols, threat models. We have learned about this DAY and CK adversary model, right?
Yes, sir.
I think someone asking about is there any other type of
No, as per my understanding, actually in my work also I have used these two model only, and other models are not that much. I think these two models are covering all the activity or all the threat kind of things for that authentication or key agreement protocol.
Okay. Sir, what is the latest protocol verification tool by which we can verify the security?
Sir, in that cases, as per my understanding, for example, if we are comparing, for example, let's consider Avispa tool are there. Okay, very few simulator are there for the security researcher, just for the analysis of the security protocol. Avispa is only telling that whether in your protocol man in the middle attack or replay attacks are there. Okay, but as per my experience, that after telling that using Avispa protocol also might be some kind of man in the middle attack or replay attacks is possible. I have seen that. But nowadays, what I'm using here for this security analysis purpose, that is basically called Cyther simulator. So in this Cyther simulator, one good thing is that I told that I think that participants has seen that several crypto equations are there, right? Some parameters are also there. So Cyther simulator is telling that just you write the code roll by as a role, and then the simulator will consider some kind of public parameter and a private parameter, and in that case, whatever the private parameter you are considering, that all these parameters should be private during the execution of the protocol, it will tell, that simulator will tell that whatever the claims you are doing, with whether your claims are correct or not. Let's take one example.
Right.
In your protocol, for example, A, B, C, D, E, 4 parameters are there. You have written the code. In that code, you have declared that A, B are public, okay, and B, C, E are private. After execution the code, the Cyther simulator will tell you whether that B, C, E are still private or not. Okay, so if it is still private, then you can assume that whatever the protocol you have designed, that is strong enough and there is no security loopholes. So
Okay.
basically nowadays that Scyther simulator we are being using, and some Pro-Very simulator are also there.
Maybe
That can be also used.
they used Pro-Very protocol.
Yes. That can be also used, but I prefer that Scyther simulator.
Okay, just a minute. All the participants, you may off your camera. We have already taken the screenshots. Now you can off your camera. And so all these screenshots we have to place in the report for submission in the auto portal. That's why.
Okay. So thank you so much, sir. Thank you so much, sir, for inviting me
Thank you very
giving
much.
me the opportunity for this lecture, for this session. I don't know how much that participant have understood, but I've tried my best to discuss this thing. Although it is very much difficult, because understanding all these things will take some time. Okay. So maybe that, as I don't know that how many researcher or how many are faculty are there. So maybe you can go through some research article for understanding, and maybe from this lecture you can get some kind of motivation, right? So to continue your research work, okay, in this domain. If you want.
No, you have done so many works, right?
It's there.
There are so many works in the field of authentication, or server-based authentication, or biometric-based authentication.
Yes.
Almost we have started in the same time, but you have done so many things in your area. That is really.
Thank you so much, sir. Thank
very
you.
nice, and you have dedicatedly doing your work.
Yes, sir. Now I'm exploring that blockchain technology, because that nowadays in future, maybe instead of centralization concept, okay, we have to deal with the decentralization, right? So that decentralization, if you want to provide a security for the decentralized, blockchain is the best choice.
Right. No, rather even if you consider your initial papers related to multi-server-based authentication,
yes.
We have made some state of art. Actually, we can say whatever I have done my research work, I have followed your published papers.
Great, sir. Great.
The ideas, and our students are also doing so many works in this area. So that's why it's really very.
Thank you so much, sir, for following my paper. It's a great thing for me. Thank you.
Thank you very much once again.
Yeah.
Okay, sir.
Thank you so much, sir. Thank you.
Good night.
So, sir, can I leave my session now?
Yes.
Okay. Thank you, participant. Thank you all. Let's go.
So now, thank you very much, all the participants. We are just going to close our sessions here, and we are just waiting for the last day, that is tomorrow. Tomorrow will start from 2 p.m. and there will be a test, as you know, from 6:30 to 7:30, and there will be 50 MCQ based questions, and type of the questions you have already got different types of polls, and just you can guess what type of questions will be there in the test. So just follow the questions already given in the poll, and then you can guess what type of questions will be there, and better you can go through the PPT we have already shared with you, because whatever the questions are there, that will be supplied by the speaker on the basis of their PPT or presentations. Right. Still, if you have any confusion, you can just knock us. No problem. You are always welcome. Okay. Thank you very much.
So, sir, test time is 6:30 to 7:30 or 6 to 7?
Yes, sir. 6:30 to 7:30.
7:30. Okay, sir.
6:30 to 7:30. Online test and feedback. Okay. And after that, we will arrange a valedictory session And there we will take feedback from the participants. And we hope you will provide your feedback. No, actually, we can set the question paper with 30 MCQ, but we are thinking in a different way. If you provide 50 questions, then you will get more options, right? Because there are, I think there are some requirement of 70% marks you have to score. So if we provide 50 questions, then you have to answer at least 35.
Okay. So, sir, the questions we can take from ATAL portal, or just you will share some Google form?
No, we will share a Google form or some link, and from that link you can answer.
Okay. Thank you, sir.
Okay. Thank you, sir. So good night, everyone.
Sir, excuse me, sir. How much time will you be giving for finishing that assessment, sir? What will be the duration of the assessment, sir?
For test, there will be 1 hour. Actually, for test, there will be 1 hour. There will be 50 questions, 50 MCQ based questions, and time will be 1 hour.